right. Hello, everyone. My name is Filippos Vasilakis. I work as a web engineer in California, where we mostly build APIs, and we help clients to move from desktop era to web era. Today, I'm going to talk about MicroTypes and how they can help us to evolve our API. So I'm going to talk about some challenges that we face. I will present MicroTypes and eventually React negotiation. That it's an alternative form of negotiation, but unfortunately no one uses it. But first, I would like to show you something that I heard in a talk by Micah Newton. This is the earliest online HTML document that we have as of today, and this is from 1990, which means 27 years old. And if you now go out and buy a computer or on your own computer and visit that URL, it will actually work. And I think this is amazing. And even the link, it will be valid. It will show you another page. And I think when we build APIs, we should think on the same way. We should think how we can make them, we can prolong their lifetime. We can make them evolvable. And the thing is that, okay, sometimes we do control the client, so we can do some breaking changes in our API and deploy both at the same time. But this is not good. And usually, this is not the case. I mean, imagine if you have an iOS app or a Play Store app. It takes 3 to 7 days to deploy a new change to the App Store. Imagine if you have IoT devices where you cannot even access them, the IoT devices. They're scattered all over the world. So we have to think differently. And I think everything boils down to evolvability. So how we do it today? Well, the idea is that the client asks for the negotiation that negotiates for the representation that it understands. And why is that? Because if it understands the representation, it means that the content will be self-descriptive for the client, and it can find things all over the content. And it can manipulate it. It can do a lot of cool stuff. And from the server side, it's important to give to the client what it asks. And we should not diversify our content from the standards, because otherwise the client will not have self-descriptive content. And one thing I should stress here is that when we say that the client understands this representation, it means that someone, a human, has actually sat down and programmed the client accordingly. I think we forget this thing sometimes. So to give you a small example here, we have an API that has different representations. We have a client. The client says to the API, you know what, I would like to have the JSON API representation because that's what I prefer. It has some cool stuff regarding aggregation. Well, if you don't have that, then okay, give me HAL. And if you don't have that, just give me serial. Of course, if the server doesn't have anything, then these two services won't communicate. But hopefully, fortunately, the server does have the first option. So it returns the option that the client asked, and the client has self-descriptive content. And we call that proactive negotiation. Now, I think what is important from this flow here is the key things are these names: JSON API, HAL, GraphQL, collection plus JSON. What are those? These are media types. So let's go and dive into media types, see what exactly they are. So media types, they follow some RFCs, but a media type specifies all your semantic functionality of your API. So it defines, for instance, a response format, its structure, the request structure. It defines hypermedia, any links that you might have, how they work. It defines pagination, sorting. It defines filtering queries, aggregation queries, so many things. For instance, I think yesterday we had to talk about JSON API. So to give you an example, I have taken some extracts from the official JSON API document, media type. For instance, it defines how the response structure looks like. It defines how the metadata looks like and where the client can find them. It defines how the pagination looks like, how we can add hypermedia. It defines how the client can do sorting, how the client can ask for relevant resources, how these resources will appear in the same primary resource related to the primary source. It defines how the client can ask specific keys of the primary source on the specific keys or attributes of the related resources. it defines how the errors will look like, it defines so many things. And why is that? Because today APIs are so powerful, and being powerful, they're a bit complex as well. And what happens if we want to evolve our API? Well, sometimes what we do is that we just add the semantic changes to our documentation. Unfortunately, this is not the solution. Documentation is good for other things, but when we evolve our API semantically by providing new capabilities and new ways of retrieving data, we have to create a new media type. That's the official, that's the formal way of how HTTP works. That's how our internet architecture works. Unfortunately, that doesn't work always either, because we have to move fast. Creating a media type, it's not that easy. I mean, for instance, if we have these are lovely JSON API error messages, and we want to follow the official RFC standard that was published last year. It's called Problem Details for HTTP APIs. And we want to evolve to that standard. We cannot just create a new media type. It's going to be too much. The same goes if we want to evolve our pagination. For instance, if we want to support IoT devices that they don't parse our HTTP body and they get the pagination from HTTP header links. If we want to add a new capabilities regarding pagination, it's not ideal to create a new media type. Or if we want to add URI templates following web links, following the URI templates RFC, it's not ideal either to create a media type. And there are so many other cases. For instance, if we want to have different hypermedia, if we want to add semantic web, JSON LD, we want to add different querying language, maybe bring some part of GraphQL to REST APIs. If we want to do even more advanced stuff like deprecating some attributes or some stuff from our API, if we want to do real-time updates on some resources. So what do? We add those stuff in documentation. Just to be clear, I love APIs that have great documentation. I think good documentation is really good, but this is not the solution to our problem, because the client has to know that stuff without someone sitting and coding every time that we do a change, without having someone in the client sitting, a developer doing the changes on the client side. I think this is my favorite quote from REST thesis. It says, a system intending to be as long-lived as the web must be prepared for change. And I don't want to bombard you with quotes, but I would like to stress that if we want to move fast in the API, regarding our APIs, if we want to make a change in our market that we are on, we have to build a change-first API. The change must be part of our design. And unfortunately, media types don't really help on that because they are monoliths. They don't allow us to evolve our bad parts of our API. They don't allow the clients to negotiate different things, different semantic things, functionalities from our API. We cannot support different classes of clients concurrently. So what's the solution? Well, one solution is MicroTypes. I'll present a second solution later. MicroTypes are small reusable models that compose a media type and facilitate the evolvability and extensibility of our API. They are also called features by Ruben Verboch and Michel de Montier. They define a feature as a part of an interface that identifies, describes, and affords a certain kind of interaction across the web APIs. These two definitions were developed independently, but it boils down to the same thing. Small, isolated description about a part of our API functionality. So to give you a high-level overview for what's that, today we design an API which defines functionalities, but in fact, we build a monolith interface. And what is even worse, sometimes we build a custom monolith interface. And why that's a problem? Because we have API-specific clients. Because we require humans from the other side to sit down and check our API, how it works, and actually spend time on that and money. Instead, I think there is a better way. I think we can design API that provides functionalities, but instead of implementing them as a monolith interface, we should have a modular interface. And these small modules should be reusable so that from the API designer perspective, it can build something bigger using these building blocks. And from the client perspective, we can reuse code and functionality. So we get MicroTypes our client. So to give you some more information about the advantages, let's go and see from the server side. So the API designer should not build a monolith as we do today, like media type, that here it is, your media type. But instead, we should try to build a small base parent media type, let's say, which defines the basic functionalities, defines the basic response request format, maybe defines also the message format like JSON or XML. And given that, the API designer should ask herself, what else do I need? I like to have a JSON API flavored API. So let's have JSON API pagination. Let's have some JSON API resource or fields querying support. And then let's have JSON API errors. So now we have a 1-point version API. We roll out our API and for a couple of years, and then we figure out that it's good to follow the standards, right? So it's good to have the official HTTP errors RFC. So it should be as easy as implementing a small model, and providing that we don't have to bump the whole API version. We should just provide the functionality to the client using redundancy. So smarter clients that are following the standards should get the RFC error messages. Dumber ones, okay, they can still get the old one. And we can, using that strategy, we can progressively evolve our API. We can add different pagination strategy. We can add, let's say, some parts of GraphQL, bring them down to REST. We can add forms or action specifications. We can even add deprecation stuff. We can deprecate older microtypes, JSON-LT, that kind of stuff. And when we reach 1.6 version here, you can see that we use our own mechanism to deprecate all stuff that we don't want the next version. So version 2 would look like that without our initial error design. But older clients can see different things. Depending how smart the client is, can do more cool stuff. But still, the old client will still work. We have it there. We don't break things. We just evolve our API more easily. But yeah, and actually, the cool thing with that is that the API designer can pick different functionalities to build a big thing. We don't have to build everything from scratch. We don't have to build monoliths. But there is more cool stuff from the client side as well. From the client side, the client can negotiate different things on the semantic level. So the client can say, yeah, I want JSON API, but I want the JSON API pagination, but I love GraphQL. So if you can give me some GraphQL functionality, I don't mean like introspection, but just the GraphQL querying, that would be perfect. If you can't do that, okay, I'm fine with JSON API. I would prefer to follow the standards. I would prefer to follow the RFC regarding error messages. But if you cannot offer that, I'm fine with official JSON API error messages. And if you don't have that combination, then I will get some HAL with just some JSON API flavor. And if you don't have that, then okay, I'll get the HAL monolith. I'm fine with that. And the server will try to satisfy the client constraints. So it gives most of the stuff, not GraphQL, but most of the stuff that the client asks. And we do that using media type parameters, which is totally fine. It's just like it's a forgotten concept in HTTP, but it's still valid. Now, as I told you, there is another solution. It's the profiling, if you have heard it. It's about the profiling relation type. Now, this idea, it is great as an idea. The problem is that the official RFC falls behind in the actual implementation. There are two things, actually. One is it doesn't really advocate towards reusability, so that the same client can talk to different APIs and they're using the same implementation. and it fails to provide proper negotiation semantics, so that the client can negotiate and give some preferences what it wants. Good news though, we have a new IETF draft that it's been working for towards that direction, and until then we can use media types. So good job. We actually broke down the monolith in smaller usable models. But what about discovery? I mean, if we don't know what the API provides, what can we do that? We have to still figure out the documentation, or we have to still, someone has to sit down and program the client accordingly to ask for the right things. So to give you an example of what I mean, here the client asks some stuff, some microtypes, but how can the client know what the API supports, right? And one thing that I didn't explain intentionally previously is that this is called proactive negotiation. And it's called proactive negotiation because it's kind of a guessing game. Either the client will try to guess what the API supports, or the client will have, the client developer will have to check the documentation of the API and will have programmed the client accordingly. And surprisingly, something that I think it's very interesting to learn today is that the RFC, the official HTTP specification, says that the proactive negotiation has some serious disadvantages. Most importantly, it's impossible for the server to figure out what exactly the client can want. It has also some other issues like privacy concerns or implementation, making the implementation a bit more complicated. But everything boils down that the server cannot provide enough information for the client to choose. And the official RFC, the same HTTP specification, says that there is another type of negotiation. It's called proactive negotiation. And what proactive negotiation does is that the user agent, after receiving a list of all the capabilities of the server, can select the ideal representation for it. Funny thing is that this is 20 years there. No one has used it. If you know an API that uses it, come later to me and let me know. But I have searched the whole internet. I didn't find anything. So to give you an example how this works, so the client first does a request to figure out what do you support. I have some stuff that my original developer did on myself, on my code. So let me know what you support so we can do some we can talk. The client responds back with what they support, like the capabilities, the microtypes, and then the client sends the actual request, requesting what it actually wants, and the server responds with what what the client asked. And the reason for that is that once the client knows what the server supports, there is no reason for the server to send back another representation. But actually, this is more cool for some other reasons as well. The client there in the first step, or maybe in the first and third step, knows much more than the server and cannot expose those information through the network due to privacy issues. For instance, it knows what is the battery level. It knows what's the memory, what's going with the CPU, what's going with the whole system. It knows a lot, and having this knowledge, it can make much more powerful decisions regarding the presentation. If, for instance, there is something wrong with the system, give me the most similar representation to just give the basic errors to the user, just to save some memory or whatever. If I am on desktop, just give me everything. I can handle it. I have an Intel super duper processor or whatever. I don't know. So this is very, very cool, I think. But the problem is, like, how can the client can do that? How can the client do a request asking the server, give me all the microtypes that you support? Well, the official RFC, of HTTP says that there is an option for that. There is a method for that. It's called HTTP options, and the HTTP options provides information about the communication options available. It provides information for the client to determine all the options, requirements, capabilities of the server. And this is from the official RFC. It's not, I mean, I think that's perfect actually for reactive negotiation. So to give you an example how this would work, the client would send an options request. The options request allows the HTTP body, so we can have the information there in the actual HTTP body. We can provide all the capabilities of the server. We can also provide all the capabilities on using web linking, or we can even use proactive negotiation. And using a microtype, we can figure out how we can transfer this information. So, good work, everyone. We broke down the monolithic media types. We added discovery of microtypes. What else can we do with microtypes and reactive negotiation? In fact, we can do a lot of cool stuff. Reactive negotiation in combination with microtypes, we can give a lot of information to the clients, maybe not necessary for the API communication, but interesting to the client itself. For instance, in our case, what we do is like we give for the response schemas or the request schemas for the client to know, and maybe give some errors above to the application level. We can do a lot of cool stuff. So what else we can do? I think a lot of research and innovation. Thank you very much.